Right, the 2008 paper. Paper 1, multiple choice. The first year of reintroduction of the multiple choice since the 80s. Quite an easy one. Let's go through them anyway. Question 1, a recurrence relation. It gives you a particular term and it asks you for one that's a couple of steps further on. It gives you U10 that says what's U12. And this formula tells you how to work out the next one given any particular one. And don't bother about what it might say for these. If that says UN minus 1 and that says UN, it still means the same thing. It means to get the following one, you carry out these operations with the one you're at just now. It could even say UN minus 2 and U minus 1 if they felt perverse enough. That would still mean the following one. As long as the formula quite clearly indicates that it's the following one you'll be working out, that's fine. So U10 is 10. So the first thing I can do then is work out U11 because the formula lets me work out only the following one. And the formula says I do 0.3 times the term you're at plus 6. 10 times 0.3, move the point forward, that's 3 and 6 makes 9. U12, that'll be 0.3 times 9 plus the 6. 9 3s are 27, move the point forward 1, 2.7 plus 6, 8.7. Answer C. Easy start. Number 2, a circle question. It tells you the x-axis is a tangent. That's handy because that circle's fixed somewhere. It's not just in the middle of the plane somewhere with no references. And it says what's its equation? Well, I'll know its centre, so that's half of the equation done. It should be x minus a squared, y minus b squared equals r squared. Well, the centre's at -7 for x, so it'll be x plus 7. And it's at 6 for y, so y minus 6. That only eliminates 1 so far from these. But the radius, well, the radius just means the distance from the centre to any point on the outside. But since it touches the x-axis, I know this distance here. That's the same as the y-coordinate. That must be 6. So it's going to equal 6 squared. That'll be 36. So the answer for that one's going to be D. Third one then, they're given two vectors, it tells you they're perpendicular. Well, straight away, if they're perpendicular, you know that u dot v must equal 0, using the scalar product. Scalar product meaning you multiply the corresponding components and you add them together to get a single number, not a vector. So it's going to be k times 0, well that's just 0, minus 1 times 4, or -1 times 4, so it'll be -4, 1 times k, so plus k, and that should come to 0. I'll just take that 4 over, and there you go, straight away. K equals 4, so that makes the answer C. Question 4. A sequence is generated by a recurrence relation. Again, we just had one, question 1, and this time it says, what's the limit? Well, did people be laughing their heads off at that question? Give me the marks, please. Just put them there. So it says, what's the limit? So you're just going to put in the limit formula. B over 1 minus a. There's a limit because that multiplying number is a proper fraction between 1 and -1. So you just put the figures in. Don't forget that it's a negative though. -240 over 1 take away 0.4. 1 take away 0.4 is 0.6. Because you're not got a calculator to assist you here. Dividing by a decimal, you don't. If you're going to do 240 divided by 0.6, change both to whole numbers. Multiply the top and the bottom by 10. That makes that 6. That makes that 2,400. 6 and 24 goes 4, so that's going to be 400. But it's a negative, -400. So that's the answer, B. Question 5, another circle question. Just one of them. And it's finding the equation of a tangent. Well, the equation of the tangent to a circle, well, the tangent's a straight line, so I'll be looking at y minus b equals mx minus a, where m's the gradient of the line, which will be perpendicular to the gradient of that radius that joins at the point of tangency. But as soon as you get the 0.79, you look at this, because it would be y minus the y-coordinate equals whatever that gradient is, times x minus the x-coordinate, and there's only one of them that's got minus 9 and then -7. So straight away the answer is A, without even bothering about that circle. You didn't need to know the centre. Because I could just have said, what's the equation of a line that goes through the point 79? Because there's only one of them that goes through the point 79. So that's the answer straight away. However, if they hadn't have done that, if they weren't just wanting to give you marks on this page for nothing, then you'd have had to work out that gradient. First of all, may as well put that down, just for the sake of doing this part. So the gradient of that radius, that'll be the difference in the y coordinates over the difference in the x coordinates. Whoops. So the difference in the y coordinates, that's 9 take away 5. I'll put it down, 9 take away 5. Difference in the x coordinates, 7 take away 2. So that's going to be 9 take away 5 is 4/5. Which means that the gradient of the tangent is going to have to be the negative of the reciprocal. If they're perpendicular, they have to multiply to give -1. So it's got to be the negative of it and upside down. It's -5/4. And -5/4 is a, but you knew it was a anyway. Dearie me. Right, number 6, a little trigonometrical equation, but a simple one because there's only one mention of x. That means all you need to do to solve it is get rid of all the bits and pieces it's buried under. Get rid of the root 3, get rid of the 2, get rid of the sign, and there you are. Right, so I'll do 2 of them. Get rid of the root 3, that'll go over as plus. Get rid of the 2, that'll be divide by 2. And then to get rid of the x, it'll be inverse sine, but you should recognise this one. Well, it's paper one anyway, you can't use your calculator. If you don't remember them, at least remember your triangles. The 60-30 triangle, half of the equilateral triangle, with sides 2, 1 and root 3. 1 the smallest opposite the 30, 2 is the biggest. And you think, right, sine, that's the opposite. That's the side without the angle, sine the angle. So that I've got, for that one, it must be the root 3/2 is opposite the 60. So it's 60 degrees. Or, because they keep repeating themselves over and over again, it could be 60, or it could be this one. It's one of those two. But you probably don't do it that way. You probably use your all sine tan cos, so that if the sine's positive, you're either in the first quadrant or the second quadrant, and that's where the 60 is going to go. You're going to put your angle of 60 there, and then your angles are either 60 or 120. But pay attention to that interval there. You only want the answers between 90 and 180. So that means this is the one I want here, the one at 120 degrees. Right, so for the answer, I'm going to have, I'll pick the bigger one, 120 degrees, but I'll have to put it back into radians. Usually you think in degrees and then stick it back into radians afterwards. So 120 degrees in radians, if you're not sure what that is, divide it by 180 degrees. That knocks out the degrees, times pi to make it radians. So that's going to cancel down to, that's going to be 6 into that's 2, 6 into that 3, so it's 2 pi upon 3. 2 pi upon 3, that's going to be answer, what is it again, 2 pi upon 3, that's answer B. So to question 7. Another thing to do with angles. As soon as it mentions angles and lines and gradients, you know you're going to be thinking of the gradient is equal to the tangent of the angle. That's the tangent of the angle measured from the positive x, remember, all the way around. So if it goes beyond 90, it's going to be negative. The tangent goes negative beyond 90. It should be negative anyway. This line is sloping downwards, so you're looking for a negative gradient. But same again, 135, where is it? If you're going to use your all sine tan cos business, you'd think, well, where's 135 degrees? It's round here, which leaves 45 degrees as the actual working angle. So the tangent of 135, the tangent of 135 is actually the negative of the tangent of whatever's left over. 45 is the one we're going to use. All sine is negative there. 45 degrees, that's one of the triangles you should know. Same as that one there. You should know your 45 degree triangle, which just goes 1, 1, root 2. So the tangent of 45 being the opposite of adjacent is 1 over 1, which is 1. So the answer is negative 1, and negative 1 is answer C. Number 8, a transformation of graphs question. They're often quite easy. Two ways of thinking of them. You can think of it graphically, how do they shift about and move, or you can think of it numerically, because here's a rule for calculating the new coordinates. Y equals f of x. This one, f of x stood for the old y coordinates. This one says the new y coordinates are going to be the negative of the old y coordinates. That's the function after, that's the answers. Inside the brackets, that's the values you put in before the answers are worked out. So this won't affect the answers, it won't affect the position of the graph up and down. This will affect where those answers go, it'll move it side to side. So if anything's happening inside the bracket, the graph's going to move side to side, or squeeze in and out side to side. And it's the opposite of whatever it says in there. So that says that you could just take that point, 3, negative 3, then say, where would the new point be? Well, the point's going to move forward 2, so it's going to move forward to 5, and the y coordinate's going to be negative, so it's going to go to 5, 3. And then you can just pick out the graph 5, 3. There's only one that's got 5, 3 in it, and that'd be your answer, D, straight away. Or you could think of it moving about, because what does it say? It says it's going to move forward 2, and then turn upside down. Move forward 2, and then turn upside down. So it's going to end up looking something like that. Well, that point again is going to be, instead of at 3, it's going to be at 5. Instead of negative 3, it's going to be at positive 3. So that's going to be answer D. Question 9, another wee trigonometrical one. Here you can see you've got these addition formulas. As soon as you're given the actual value, a fractional value, a rational value for sine or cos or tan, put down your triangle. So you can reconstruct the triangle that A was in. The sine is 3/5, sine's the opposite, the side without the angle. The 5's the hypotenuse. Then you should recognise that as a 3, 4, 5 triangle. This bit was just mentioning it's acute, simply so that the sines and the cosines and the tangents are all positive, so there's no negatives coming out of this. Right then, for the sine of x plus a, if you can't remember, you've got it at the front there. So that's going to be sine x cos a plus cos x sine a. Now there's nothing we can do with the x's, so I don't know what they are. We can certainly put in these things. I know that sine a was 3/5 and cos a is going to be 4/5. And then just putting that to the front, so 4/5 times sine x plus 3/5 times cos x. And that's as much as you can do with it. So that gives you the answer B. Number 10, statements about the roots of an equation. As soon as it talks about the roots of a quadratic equation, you know you're going to be using the discriminant for that. Where the cases are for the discriminant, b squared minus 4ac, the part inside the square root. If that's less than 0, there'll be no answers, because the square root of a negative doesn't give real solutions. If it's equal to 0, there'll only be one answer, but it'll be real, because plus or minus 0 will make the two answers the same. And if it's greater than 0, you'll get two distinct real answers. But don't forget the case where, if it's greater than 0, and it happens to be a perfect square, that means your formula, negative b plus or minus the square root of the thing over 2a, if that's a perfect square, then it'll be exact numbers. It'll be a rational answer, because you'll have whole numbers over whole numbers. If it's not a perfect square, you'll have irrational answers. But it's not asking for that to find a distinction here. It's just saying, what have you got for that? Well, what have you got for that? B squared. That's 1, take away 4 times 1 times 1, take away 4, that's negative. Doesn't matter, it's negative 3, but the only point that matters is it's negative. That means there's no real answers. So not only are they not equal, they're not even real. So none of them apply. It was a multiple selection question. So you'd have to answer yes or no to each of them. The roots are equal? No. The roots are real? No. So which selection's there? Neither is correct. A. That's that. Number 11. 3 points, typically found later on, where it would say prove that the 3 points are collinear, and then find the ratio in which P divides EF. But here it's telling you they're collinear. If you were trying to prove they were collinear, then you'd have to work out the two vectors, the two displacements. You'd have to work out E to P, and then work out P to F, just by doing the usual P minus E, F minus P, subtracting the position vectors. So you would be subtracting them all. You don't need to do this in this question. I'm just mentioning this part of it here. So P minus E, that would be 1, 5, 7, take away negative 2, negative 1, 4. That would be 7, 17, 13. Take away P, which is 1, 5, 7. And then that would give you 3, 6, 3. And that would give you 6, 12, 6. And you can see that that's double that. And then you'd go through the process. You would say EP is equal to 3 times PF. And you know that because for it to be a multiple, the individual components must all be the same multiple of each other. You would demonstrate that, for instance, by doing this, by saying, well, if I divide them, 6 over 3 is the same as 12 over 6, is the same as 6 over 3 again, which equals 2. And then your statement would follow from that. So that EP equals 2 times PF. If you were trying to prove they were collinear. But if you know they're collinear, that means each of the components must be the same multiple of each other. So to arrive at this 2, you'll need to use one of them. So the way to have done this question then would have been this. You would simply have said, right, they are collinear, so each of the components is the same multiple of each other, of the two vectors, so just consider the 2. It says, so I would write down this. E to F, P divides it somewhere. I just need to work out how big a step is that compared to how big a step is that. Well, just pick any convenient one. The Z components look good because there's no negatives in them. So E to P is 4 to 7. 4 to 7 is 3. P to F is 7 to 13. That's 6. And there's your ratio straight away. Since you knew they were collinear, you could just have taken any of the components and just worked out the steps it took to go between them. So that means EP to PF is 1 to 2, cancelling it down. 1 to 2, which is answer B. So for question 12, there's a cuboid there, and it's giving you the vectors that represent the directions of the 3 edges. Now, vectors aren't unique to any particular position. This vector F that goes from S to R is the same as the one that goes from T to U, or W to V, or X to Y. Same with H. That's just an example of H. Any distance upwards in that direction is going to be the vector H. And then in vectors, if you have to find a particular route, if you want to travel from V to T and you don't know how to get there directly, then you have to follow paths that you know. And I know all of these paths that form the edges, so you can only travel along the edges. If you were just crawling along the edges of this framework here, then there's several ways to get to T, but they're all equivalent to each other. They're all going to involve going out along one of these edges. They're all going to involve dropping down one of these edges, and they're all going to involve going along one of these short edges. So it's just a case of which order you want to do them in. So if you start in the same order, they've got F, G, H. If I want to go along this edge first, then I'm going against the direction of F. I'd have to crawl along against the direction of F, and then if it wants G next, I'm going to go with G. So you're going to go whooshing with G, but then I'll have to drop down against the direction of H. So that's the answer there then. I'm going to go against F, with G, and then finally against H. So that gives me the answer for that one for question 12C. Number 13. There's a parabola drawn and you have to find its equation, which is just the reverse of if you knew the equation, how could you draw the parabola? Well, if you knew the equation, you would start off with the equation, you would factorise it, possibly taking out a common factor, factorise the remaining quadratic part to 2 brackets, and when it's equated to 0, to find the zeros, to find the roots of the equation, you would then extract these 2 numbers from it. So you know that if you were working that backwards, it should have looked like this. It should have ended up with x minus 1 and x minus 4 as the 2 brackets. Now straight away, that leaves you with A or C. And the next stage would have been to find k. I'd have to have some other point here. There's no point in putting in the point 0, 1, 1, 0 or 4, 0 into that, because as soon as you put in 1 or 4, that term just disappears and k just gets dragged down the plug hole with it. So some other point that would do. You'd put in 0, 12, 0 for x, 12 for y, leaving k as the only unknown, and then you could solve it. But you don't need to do that here because there's a couple of possibilities. Is it, it says 3 times that, or is it 12 times that? Well, if you put in 0 for x, then that's going to give you positive 4 times 3, which is 12. That's going to give you positive 4 times 2, which is 48, which is wrong, because the answer should be 12, which makes that the correct answer, A. And so question 14, an integral. An integral with a little trig function in it. Now you can only integrate these trig ones and other ones, which are functions of functions, if this part here is linear. If that says something like sine x squared, you couldn't do it. But you can do it because it's linear. And so the answer to that's fairly quick. Sine. Sine would have come from cos. That part's obvious. It's going to be the opposite one. But cos would have produced a negative sign when you're differentiating. It's not negative, so this must be negative here then. So it's going to produce negative 4 cos of the same thing. Don't change that part. Or don't try and integrate that part. What would happen if you were differentiating that would have been, you'd have changed that to negative sign of the same thing, and then multiplied it by the derivative of the inner function. Which means if you're integrating, you've got to do the opposite, which would be divide by the derivative of the inner function. So I'm going to divide by 2, so that'll be times a half. Don't forget the plus c. So that's just going to give me negative 2 cos of 2x plus 3 plus c, which is answer, where are we? B. And so to 15. Like 14 involving a function of a function. If that was simply x squared, the answer would be 2x. But it's not x squared, it's something else squared. Well, its derivative will just be 2 times whatever it is, and then power 1. And then you multiply that by the derivative of the inner part. And that's why they call it the chain rule, because then it's just going to form, if that had then some other function in it, you could form a third link. So the derivative of the inside part is going to be just 3x squared. And then take those parts to the front. So that's going to be 6x squared times x cubed plus 4. 6x squared plus x squared 4, so that would be answer C. 16. Put it into this form, complete the square. Well, complete the square means that's 7. That's not going to work, so we're going to forget that just now. But to complete the square, the only easy way to form these squares is when it goes x plus something squared. Because it's only then I know it's definitely square the first, square the last, and then the middle, twice the product. I don't want the 2 messing up. So the next part would be, take out the 2, no matter what. The part where there's a common factor of naught. It happens to be here. So I've got 2x squared plus 2x, and forget the 7. Then, that x squared part, complete the square for that. That would be x plus half of whatever that is, goes into it. So it's going to be x plus 1 squared, to be doubled. But that introduces an extra term, because it would be square the first is x squared, twice the product is 2x, but where's the plus 1? There wasn't 1, so you'll have to subtract whatever that is squared. And then that 7 is still waiting outside to see what's going to happen. So that gives me 2 times x plus 1 squared, 2 times this, minus 2, plus the 7. Now the 7 can come in, so I've got 2 times x plus 1 squared plus 5. So if the question says, what's the value of q? Q was 5. And q was 5 was answer A. Question 17 then. A function is given by this, and you're looking for the domain. Now the domain are the numbers that go in, domain like home. The range are the answers that come out, like going out in a firing range. So this is saying not what kind of answers can I get, but what kind of numbers can I put in. Normally you can stick any numbers in, but because of this square root, you can't put in something that would create a negative in there. 0 would be fine, square root of 0 is 0. So that means that whatever I put inside, which is this 9 minus x squared, that 9 minus x squared must be greater than or equal to 0. And that's what you have to solve to find this. But watch, this isn't an equation. Still do it the same way as before. There's several ways of doing that. I could rearrange that, because I don't want that negative x squared. by multiplying them by -1. That's fine. So I've got x squared minus 9, but now it would be less than or equal to 0. I'm probably happier looking at that equation, or rather inequation. But the way you solve an inequation isn't by factorising it and then forming two little linear inequations. You have to think of the picture of the answers. What would that look like? That's a parabola. That would look like this. I could have done it straight from that one as well, I know. A parabola which says x squared is the normal one, shifted down 9. That would be a picture of all these answers. And I want to know, when are these less than 0? Well, I can see when they're less than 0. They're less than 0 between wherever it cuts the x-axis, because the x-axis separates the positive from the negative answers. So you could do your factorisation as before. You could do your x minus 3 times x plus 3 is less than or equal to 0. But what you wouldn't do is then try and form two separate linear ones. X is less than or equal to 3. X is less than or equal to -3. You wouldn't be doing that. You'd be doing this part solely so you could solve the equation equal to 0, which would give you your 3 and your -3. But your graph's going to show you when you're above and when you're below. And your answers will be negative if you choose any x in between them. Choose that x, the answer's down here. A graph is a picture of the answers. So the solution to this is going to be, I'll have to be less than or equal to 3, but more than or equal to -3. So, correct answer for that would be part C. Question 18. Scalar products again. Now there's no picture here. It's giving me the lengths of the vectors p and q, but it's not telling me which way they're heading, which means that I have no idea what p plus q looks like. P plus q, I have no idea what that vector there looks like, so I can't use that part of it. So as soon as I see that and there's no picture that I can relate to that, I'm just going to have to split it up. So it'll be q dot p plus q dot q. So it's the scalar product. Not using components, I'm using lengths. Now there's no angles mentioned either, but still it's only paper 1. The scalar product means it's the multiplication, if I've got two vectors p and q, it's the product of their lengths that go the same way. If p is not going the same way as q, then only a part of it. It's as if you had an object here and it was on a track and you were pulling against it in this direction. Some of the force you're applying is just pulling it sideways, which creates no motion. It's only the amount of the force that goes the same way as q that actually does any work. The scalar product is this product then, the product of the two lengths that go the same way. So in this case, p dot q would be, if that angle's theta, this part of this right angle triangle, the part adjacent to the angle is the cosine. P dot q would be the length of p times the length of q times the cosine of the angle. We're not told any angles here, but you don't need to because there's other information that's been given anyway. So the handy things are this. So there's two special cases would be with scalar products. If the vectors were going exactly the same way as in the case of q in itself, then it'll just be all of one times all of the other. So it just must be q times q, which is 4 times 4. P and q are going in different directions, but I don't know the angle between them. But it doesn't matter because it tells me anyway. Q dot p, p dot q. It doesn't matter which way around you multiply numbers. Q dot p is the same as p dot q, so I knew that that part was 10. So I've got 10 plus 16 is 26. So the answer for 18 then will be C. Number 19. An exponential graph here. There's the exponential equation there with the unknown part m, and it's just saying what's the value of m. Oh, it's always the same. Here's an equation. It mentions x's and y's. It's a coordinate equation. There are 3 letters here, but these 2 stand for coordinates. If I want to find any one letter, you need to know all the rest. There's only one unknown left, which means if you've got a point, you can fill in numbers for these, then it's only m to find, so you just put the points in. So y is 54, when x is 3, equals 2 times m to the power 3. Just write the other way around. M to the power 3 would be 54 divided by 2. 54 over 2, which is 27. Then finally get rid of that 3. Power 3 goes across as cube root, power a third, cube root. So it's the cube root of 27, and you should know your basic little cubes. your 2 cubed is 8, and your 3 cubed is 27, and your 4 cubed is 64. So that comes out as 3. So the answer to that is 3, which is B. Last one in the multiple choice, or the objective set as they call it now. Another graph, this time not the exponential graph, but its reflection y equals x, its inverse, the log graph, those being inverses of each other, which is the way you'll be solving this particular equation. Same as before, you have to find the value of q. So it's an equation. There's only 2 parts that you don't know, y and x. To find one, you need to know the other. It's a coordinate equation, y and x stand for x coordinates, so you just put them in. So 2's going in for y, and q's going in for x. So I've got log base 3 of q minus 4 equals y, which is 2. I just wrote the 2 from this side to this side, because you want to solve equations with the unknown on the left anyway. And then the very first step is this. Get rid of that function. If I'd said sine there, you'd have gone straight over to the other side with inverse sine of 2. The inverse of log is the exponential. So straight away, log base 3 this side will be 3 to the power on the other side. So 3 to the power 2. Notice the 3 is the base of the power, the base of the log. So that means q minus 4 is 9. So q is going to be 9 plus 4, which is 13, which is D.